Hi, Professor. This is Yilin Zhong. I'm here with my assignment number 7 hash. We are asked 4 questions in this assignment, and I'm going to explain one by one how I answered the 4 questions. So first question is, a hash table that hashes all values to the same slot is essentially equivalent to what? So that depends on the collision strategy. So if you use open addressing, so basically when there's collision happen, we move the value to the next open slot, then the whole hash table will essentially become an array. And if you use chaining, and we're going to chain all the values in one single hash slot, and that will make this structure basically equivalent to a linked list. So the second question, analyze the hash function. There are 4 hash functions decided in the PPT provided, and I'm going to elaborate the benefit and drawbacks of each function. So the function is lose-lose hash function. So this hash function is a simple hash function. It basically calculates hash value by adding all the ASCII2 value of the character in the key. So as I said, the benefit of this hash function is basically because it is simple, it is easy to calculate, and the speed is fast. However, because it depends on the ASCII code of the key, so if the keys are similar, like they have the very similar prefix or suffix, or only 1 or 2 characters are different from each key, then the collision rate will be high. The second function is RS hash function. So this function, we define 2 values A and B, and we calculate the hash value of each character by this formula. So we multiply this hash value with A and add this character to give the hash value, and then we multiply A by number B. So the benefit of this is, again, the speed. There's only 3 calculations for each step, for each capture of the key, and it provides good distribute because if we tune the value of B, we can make the hash value very good separated through the table. And the drawback of it is because it's a simple calculation and it's easy to be reversed, so it's more vulnerable for attack. And the third hash function is DJB2 hash function, and this function is basically using this formula. So we move this hash value by 5 and add itself, then add C. C is the character of the key that we're going to hash. So basically, it also provides good distribution and low collision. Basically, we can tune this 5 here to give a low collision. The drawback, again, is because it's a simple hash method. If we figure out this 5, we basically figure out how the hash function is calculated, and leaving this algorithm more vulnerable to attack. And the 4th method we have here is SDBM hash function, and this hash function is kind of similar like the one we had. It is move it by 6. Move it by 16, minus its own value, and add the character C, which is the character of the key. So this is a much more complexity than the earlier, making it less vulnerable to attack, and also stays simple because those are all calculations can be very fast calculated by CPU. So the function has a high speed performance. However, it might potentially produce a high number of collisions, except when the keys have similar distribution of characters, because basically it is again based on a character hash. So if the character distribution are similar, the collision rate will be high. Then we go to our third question. We're going to analyze two methods, open addressing and chaining, these two collision handling methods in hash table. So for open addressing is basically if we found collision for one element, we move this element to the next open slot, or we move it to next open slot given by some algorithms, and we can define that algorithms. And benefit of this open addressing is, firstly, we are not building a chain, we're not building a linked list, so it's more memory efficiency because we don't need to store all those pointers. Again, it is basically for the same reason, it's more cache efficiency because we are chaining all the data in a continuous block of memory. So it is with more cache efficiency. The data will not scattered through the caches. And also because we're just looking for another slot, open slot, making this method more simple and easier to understand. The drawback will be, so if there are a high load factor, meaning there are more elements compared to the hash table, and because the hash table usually we maintain a capacity of 85 or 75%, and here we are not chaining multiple elements in each slot, so we basically each slot we're storing one element, making this more vulnerable to a limited load factor. The second drawback would be clustering. So basically, when we have a collision, all the elements will be inserted to adjacent slots of the hash table. So elements will be gathered into clusters amongst hash table, and if there's large cluster, it will lead to a longer search time, and it's hard to delete, because if we're going to delete one element, we can't just delete it from the hash table, because simply deleting it will leave empty slots there, which will cause issues when we search for element with the same hash value. And the other collision cope method is chaining. Chaining is basically when we have collision, we chain that values as a linked list in that which the head of the linked list we store in that slot of the hash table. So benefit will be, of course, as we basically storing multiple values, in one single slot, we have a higher tolerance of load factor, and deletion will be easy because that is basically going to delete element from that linked list, and it has higher flexibility because essentially chained, and linked list is more flexible than the array. And drawback is, of course, because we have linked list, we need to store all the pointers references, so there will be higher memory overhead. And because the linked list is shattered through the memory, through the cache, it will also have a least hash inefficiency, and also it is more complex as required to additional data structure as a linked list. So the fourth question is, what strategy and issues should we consider when we're resizing a hash table, and what are the likely complications? Okay, so when we're resizing a hash table, the first thing we need to consider is a load factor, because we don't want the hash table to be too full. In that case, there will be many collisions and reduce the time of lookup time and insert time. The other thing is when we resize hash table, we might need to recalculate the hash. That is rehashing, because some hash methods depends on the size of the hash table. So when we have a larger table, we might need to rehash it. And the third is data migration. Because we are resizing it, we might need to migrate the data from the old table to the new one. And also, similarly, there are memory allocation issues. Because we resize the table, we might need to allocate memory for the new table, and which costs more spaces. To address this issue, we have these 4 different methods. We can dynamic resizing. We can rehash using a strategy that minimize collision, and we can migrate the data using some strategies to minimize the risk of the data loss. We need to keep in mind that there might be data loss involved in data migration, and for memory managed strategy, we can pick a memory management strategies that can minimize the fragmentations to cope with the memory loss and migration of data. Okay, thank you, Professor.